Hypothesis: field resonance theory, a field-based interpretation of light, matter, and resonant logic. Author: Lake Gullickson. Introduction: field resonance theory proposes a paradigm shift in physics by redefining light, radiation, and particles as localized field reactions, termed realsions, triggered by alterations in electromagnetic, gravitational, or quantum fields. This theory suggests that phenomena traditionally viewed as objects or waves traveling through space are instead instantaneous local responses within fields, fundamentally altering our understanding of causality, energy transfer, and physical reality. Core concepts: 1. Realsion. A realsion is a discrete local response within a field, occurring when the field experiences a disturbance or alteration. Unlike conventional particles or waves, a realsion is not an entity in motion but a momentary field event, observable as photons or particle-like phenomena. 2. Realsion velocity. Realsion velocity is defined as the maximum rate at which a field can locally respond to changes, equating to the speed of light, c. In vacuum conditions, variations in apparent propagation speed through media are interpreted as differences in field responsiveness, not as physical objects slowing down. 3. Photon as a local event. Photons do not travel from emission to detection as continuous particles but manifest as localized realsions. This model explains phenomena such as quantum entanglement and double-slit interference, as photons arise independently at the point of detection in response to field conditions. 4. Energy as local resonance. Energy is not transmitted physically across space but expressed locally through field reorganization and resonance. Global energy conservation arises naturally from field symmetries, with energy appearing discretely as a sequence of local realsions. Analytical tools. 1. Spiral math. Spiral math is a conceptual framework designed to model reality using resonance, rhythm, and fractal patterns rather than linear trajectories. It emphasizes predictive harmonics, recursive geometry, and meaningful absence, offering a mathematical language suited for capturing the dynamics of realsions. 2. Shadow logic. Shadow logic complements spiral math by analyzing the absence of expected events as a form of informational signal. It quantifies meaningful non-occurrences, providing insights into hidden field states or conditions that conventional observation methods might overlook. Illustrative case studies. Nuclear detonation. A nuclear explosion is reinterpreted as a simultaneous cascade of local field reactions, realsions, from initial neutron field collapses to photon emissions, light flash, and macroscopic pressure waves. Each observable effect is a discrete local realsion event rather than a transmission of energy through space. CERN particle experiments. Particle tracks observed at facilities like CERN are understood as patterns of realsions, not trajectories of traveling particles. Particles such as muons or the Higgs boson are stable realsion patterns emerging from field responses, not persistent physical entities. Experimental implications. Field resonance theory suggests specific experimental approaches. Modified double-slit experiments to test the presence of localized responses versus particle-like trajectories. Resonance plate systems for mapping realsion patterns across different materials and fields. Delay-based pulse experiments designed to measure variations in realsion velocity across different media. Broader implications. Physics provides a unified reinterpretation of quantum phenomena, potentially resolving wave-particle duality and quantum paradoxes through a field response model. Technology inspires new methods in communications, sensors, and shielding technologies based on resonance and field modulation rather than traditional electromagnetic transmission. Philosophy and perception invites a philosophical shift from viewing the universe as objects in motion toward understanding it as an interconnected field of responsive potential, emphasizing the informational role of absence and resonance in perception. Next steps for development: further mathematical formalization of spiral math and shadow logic. Concrete and predictive experimental setups to distinguish field resonance theory from conventional quantum mechanics. Engagement with scientific communities for collaborative refinement, testing, and validation. Conclusion: field resonance theory proposes an innovative and comprehensive framework that challenges traditional physical paradigms, aiming to reshape our understanding of fundamental physical interactions through a field-based, reaction-driven perspective.